Yeah.
Yeah, thank
So
you.
we can actually start. It is 45, so I am delighted
Please.
to have Phil Shen, the general manager of Smooth and Sharp slash Direct on Paper, if I'm allowed to say that, as you see in his background. And Phil is, yeah, general manager joining us from Taiwan. So thank you for staying up late, dear Phil. And he will tell us about bonding process of flexible IC and single loop printed NFC. So Phil, with that, the stage is yours.
Yeah, thank you very much, Christoph, for your kind introduction. And thank you to everyone who listened to my presentation. I'm Phil Chen, the General Manager of Smooth and Sharp Corporation, Taiwan. On behalf of Smooth and Sharp, I'm great to be here to talk about funding process of flexible IC and the single loop printed NFC. First of all, let me give you a brief introduction about my company. We founded in 2002 for a smart car business, and we were a simple RFID inlay manufacturer at that moment. After a decade, we found the HDR antenna, which practice tons of plastic. It's a problem for the environment. After RFID inlay penetrated the industry, then we concentrate on paper printed with additive manufacturing solution. In 2015, we printed electronic or RFID antenna on paper. Last April, we created the first and the only ISO-certified biodegradable RFID antenna, DOP, direct on paper. And last July, we built up the production line for NFC biosensor strip. Regarding our capability, we always engage with customers from prototyping to mass production. We are a small company with limited resources. From design to production, we control a minimal budget and provide a reasonable price for customer. And our roadmap from more components added, such as lighting 7 LED and multi-layer, including one layer UHF plus 3-layer NFC. Based on paper printed, we use different substrate, for example, PET and PI. More complicated circuits like ECG for healthcare. The fine line and gap are around 100 micron. Unique mechanical design, such as a plug-in NFC biosensor strip. All right, let's cut to the chase. Why does flash IC matter? It enables item-level traceability from the factory door to the end customer and the Internet of everything. A cost-effective, almost 80% lower inlay cost from a fully flexible construction and ultra-thin label without bump in the inlay service. Because the chip thickness is only 30 micron, even thinner than a human hair. Talking about the carbon impact of semiconductor manufacturing, it's 100 times lower energy consumption, 100 times lower water consumption, and 1,000 times carbon emission for sustainable low power carbon manufacturing. A conventional silicon chip, such as N-Tech, the size is around 0.5 by 0.7 millimeter. It's easy to run the pick and press for dry inlay in the chip bonding process. In the video, the head of the pick and press is very tiny and sharp. The big size and the soft flex IC for chip assembly is a big challenge. The size of flex IC is 3 by 1 millimeter, almost 50 times bigger than a silicon chip, and the chip thickness is only 37 microns, around 3 times thinner than a silicon chip. From the picture, you can tell the difference. The first IC is large and soft, but the second chip is tiny and stiff. So how to handle the first chip with a standard chip bonder? Okay, let's sort out the chip bonding problem. How about the die release mechanism from the boot tab? Then how to transport the first IC from the wafer to the antenna and placing mechanism between antenna and the anisotropic conductive adhesive. Other relative parameters such as the pressure, heat during the chip bonding, wide angle AOI inspection for a big chip, and so on. In the drawing, you can see the bending stress on the flash IC. How to release the severe bonding stress on the flash IC? We use a thin printed antenna to reduce mechanical strain during the chip bonding, and the target thickness is only 2 micron. For screen printing antenna, we try different shape, size, and thickness for a suitable antenna design. Talking about the bespoke solution for flash IC, from proof of concept by manual chip bonding, you can see the chip flex IC as a bridge across the multi-track, and the thickness of a single loop antenna is only 2 micron. When flash IC meet DOP antenna, so many advantages. First, a unique NFC network with a single loop antenna. We can save material process, which means more green. Second, our DOP antenna is the first and only certified biodegradable RFID paper antenna. In addition, the most sustainable RFID inlay is green with lower carbon emission, which means green in chip manufacturing, green in antenna manufacturing, green in inlay assembly. One-layer structure versus three-layer structure. The difference is DOP can print the information on the backside of the antenna, but a conventional H-alumni inlay should be covered with an extra layer, adhesive and printed paper. DOP, the round paper, which has the European standard EN 13432, and we get a stigma mark. We know the mass production of a new product is always a headache. The chip bonding speed is 7,000 pieces per hour for silicon chip, but only 2,000 pieces per hour for flash IC. We target an output at 8,000 units per hour for customized chip bonder. So how to achieve the goal? First step, we use row-to-row screen printing for NFC inlay on a mass production scale. Then, how to certify the chip bonding quality? Sorry to cover the chip bonding area. Due to NDA, we cannot disclose this to third party. It's critical for high yield production. To measure the robust and the durability of NFC inlay, the final inlay have to run the RFID endurance test, and the test condition is the loading speed at 20 meters per minute, reverse every 30 seconds, and the run is 1,000 cycles, including forward and reverse rolling, each one 500 cycles. The test result seems acceptable, but there is still room for improvement. In conclusion, NFC flash IC can be assembled with an etched aluminum antenna by providing a connective bridge across two ends. In our concept, the ultra-thin flash IC match our ultra-thin DOP antenna. The benefit are the material, process, and the resource saving during the inlay production. Use a single loop antenna without the connective bridge. We can avoid additional printing or a double-side aluminum antenna substrate. The most important is a tiny resource saving in one inlay with NFC flash IC for trillions of smart objects and beyond. Thank you. Thank you.
Thank you very much, dear Phil. Very good presentation and awesome work you do at Smooth and Sharp. Also shout out to Ellen, of course. And applause is coming up. Of course, you can't see it, but the audience is very happy with your presentation. So to the audience, of course, you yeah, feel free to add your questions to the chat. I will crash ahead, Phil, with a question. one I've prepared. Why didn't you choose the thicker antenna instead of 2 microns for better electronic performance?
Oh, it's a good question. Indeed, the thick antenna can lead a better electronic performance. But as I mentioned, remote bending stress with a thick antenna in the both sides, you can see the bending stress is very severe for a fast IC. Also, the more conductive ink means the higher cost for NFC inlay. So I think it's good enough and suitable for NFC. It's belong to near field communication. Thank you.
Very good. Uh, Duncan would like to know, Duncan Lindsay, hi Phil, what screen printing inks do you use? Is it silver? And if it's silver or any other, do you develop them in-house?
Yes, we use the silver ink. It's correct because it's good for conductive property. And we cooperate with our ink supplier to develop the new ink. So it's a brand new with a new recipe only for us. Thank you.
Very good, very good. Um, Evgenia would like to know what is the substrate thickness and is there a possibility to make it or thinner for conformable applications, for example?
Yeah. The substrate thickness. Our substrate first is the paper, and our thickness is around 110 micron. We also can try different thickness, such as 170. We also can do the thinner paper, such as 90 micron. I think it depends on the application. So maybe if you want to do the thicker or thinner, we can customize it. Thank you.
Very good. Impressive work. Evgenia, feel free to get in touch with Phil. You see his email address here. And
Yeah.
Smooth and Sharp will also be in Berlin. So if you want to meet Ellen or Phil or both in Berlin, feel free to visit us later this year. They will display some interesting, very interesting devices. Phil, with that, I would like to close the presentation. I thank you very much for your time and staying up late.